Now. Hello everyone, and welcome back to a video discussion. Amos, Zweig, and myself. We are today going to discuss the issue of evolution, the theory of evolution, and related to that, the theory of intelligent design and some issues about this. So first of all, one could point out that this is a very important issue, because what a person believes about the origin of man and life will affect how he views many different things. It has been argued that the evolutionary theory sort of invites a view of humanity that is less dignified than, you could say, the Christian view, because it views human beings not as very distinctly different from other animals, but just one animal developed to a certain degree instead of there being some real qualitative difference. But and someone would perhaps say that, point out that communism is actually based upon some evolutionary ideas. So that's one thing to point out, that what you believe will determine what you think about many other issues if you have certain beliefs about this subject. And of course, the issue of does God exist, which religion is true, of course, also touches upon evolution and intelligent design. Okay, so I oppose evolution. I don't believe in it because it's not compatible with, first of all, Catholic teaching and the teaching of Scripture, but also I would say there are philosophical problems with the theory of evolution. And when it comes to the scientific issues, I'm not a scientist myself, so I'm not an expert, I'll admit that, but what I have seen so far when it comes to science, I haven't seen any real evidence for evolution actually happening. And it seems to me to be scientific evidence against the theory of evolution. And I've been reading in a book which I recommend people to read. It's called In the Beginning, Compelling Evidence for Creation and the Flood. So it argues for intelligent design, special creation, and also the worldwide flood as described in the scriptures. It argues that from a scientific point of view. And it has a lot of footnotes from mainstream scientific books and journals, etc., etc. So it's very recommended. Okay, so I'm not sure whether you want to just dive into some of the arguments or share some thoughts about the subject in general, or what do you think?
Yes, I mean, we had a part 1 where we discussed mostly the theory of evolution, and I presented Richard Dawkins' take on how this works. And so I think it would be very good if you could present some of the most compelling arguments for your point of view. And then afterwards, we can discuss these arguments, and perhaps you can present some more. So that would be, I think, an interesting part too.
Right, yes. Perhaps the part 2 can be more about the philosophical arguments, because there's a book I plan to read called The Metaphysics of Evolution, which will be more deeply into that, but we might touch upon those issues anyways. We'll see, perhaps.
No, we could also talk about the philosophical implications of different of evolution and of other theories. That would also be interesting. So I think it's something I haven't thought about in a great depth so far.
Yes, that's very true, but I was more thinking about the philosophical arguments against whether evolution is true or not, rather than implications. But I'm open to both, of course.
Okay, so perhaps, yeah, just start with one that you find most compelling, and then we will see.
Right, so one argument, a philosophical argument, is dealing with, it's based upon some Aristotelian philosophy, based on the philosopher Aristotle, and I found that to be very interesting. It would say that material things around us are composed of matter and form. That means that when we see some material thing around us, could be anything, it has sort of two aspects to it. One is what the thing is made of. and the other one is the form, that which organizes the matter and makes it into the kind of thing it is. And there are examples with this when it comes to mere human artifacts, like a chair. The matter of the chair is, the specific material which the chair is made of, and then the form is all those materials being arranged together, organized together to make that specific chair instead of it being something else. But that's a human artifact, so it's more, you could say, real when we consider things in nature. For instance, all sorts of living organisms, it's made up of cells and organs, and then there is the form, which is that which organizes that organism or all those material things or parts into an whole and thing which is with a specific essence. And this is called substantial form. That is that which gives a thing its substance. Because substance, that means that a certain thing, there is something about the thing which makes it into the kind of thing it is. So it's sort of related to the philosophical concept of essence, the essence of a thing. The essence of a tree is tree, to be a tree. The essence of a human being is human nature. The essence of a dog is to be a dog, etc. And you can sort of talk about substance in the same way to a certain degree. Okay, so the thing is, so this is the truth. This is a true principle about material things, how they are. They are composed of matter and form. Matter, what it's made of. Form is that which organizes the matter and makes it into the kind of thing it is. That is substantial form, to be more precise. So we discovered then a philosophical principle that form determines matter. Matter as such is just potential. It has the potential to be all sorts of things, but it cannot be a specific actual material thing unless there is something that literally informs and organizes the matter into a specific type of thing. Even if someone were to say, well, what about atoms? Atoms not organized into anything. Well, even one atom is actually composed of matter and form. You could say the matter is the elementary particles like electron, hydrogen, etc. No, not hydrogen, but electron, proton, etc. And then the form is all those particles and all those material phenomena organized into making that an atom instead of something else. So everything is matter and form when it comes to material things. Now, so since the form, the substantial form determines the matter, it determines how the matter is going to be. That means that it's impossible for the matter to change the form, since form determines the matter. And someone might ask, well, how is this relevant to the theory of evolution? Well, what we see in the theory of evolution, at least how I understand it, the Darwinian idea that the diversity and complexity of life and species originate from one common ancestor and develop through mutation and natural selection, involves that through the process of mutation over a long period of time and a huge accumulation of mutations will eventually change the form of an animal. At one time it could be a fish, but then many years later it could be an amphibian, and then eventually, according to evolution, it's all sorts of animals from platypus to dogs to cats and even human beings, according to many evolutionists. So then we see an animal having changed form, the substantial form, a very much radical change over a long period of time through mutation. But that means that the matter of a living organism has changed the substantial form. But that's, as we said, is impossible because matter is determined by form, not the other way around. It's the form which limits matter and determines what it can and cannot do. To take an example, a tree has the substance or nature of a tree, and it's impossible for anything within the material mechanisms of that tree to do anything that is outside of that nature. For instance, there is no way a tree can, by some genetic phenomena within itself, suddenly begin to speak or walk, just to take a hypothetical scenario. And we recognize this is impossible because it's not in the nature of a tree to do these things, or even have feet to walk with. Even if you have billions of years and billions of mutations all those mutations will always be limited to within the essence or substantial form of the thing. Yeah, so that would perhaps be called the argument from hylomorphism, and that's one argument against evolution. So what do you think about that?
Yes, just 1 second. I was wondering, why would you say that the process of evolution presupposes that matter changes the form? I would rather say it's the interaction of different entities that change the form over time. So you could just as well say that the form of one thing changes the form, or no, one entity changes another entity a slight little bit, and that happens many times after each other, which results in a large change in the end. So it's not the matter that changes the form, but it's one object with form and matter that influences another object with form and matter. That's, I think, my initial thought or question to this argument that you have presented.
Well, I'm not sure if I quite understand what it means that the form of the thing is changed by different entities, because as I understand it, when it comes to mutations, that is an internal material genetic change within the thing itself.
Yes, but as you have said, if even an atom has form and matter, then of course also the genetic material of an animal has form and matter. Namely, the matter would be the different particles out of which this complex molecule is formed, and the form would be the actual structure of the molecule. And so if there is a mutation where one I don't know, one of these proteins or building blocks is swapped by another one or gets missing or something, then the form also changes. It's not just the matter that does something.
But even those changes with atoms, that is a change in the matter of the organism.
How so? How is it only a change in the matter and not in the form as well?
Well, the dispute is whether it changes form or not, but just looking at whether it changes, whether it is a material change or not, I mean, it's about the atoms within that organism changing somewhat or arranging itself differently. But when it comes to the atoms of a thing, that is the matter of a thing, that is what the thing is composed of.
Yes, sure, but when you change the way these atoms are organized, then you change the form, or the form changes.
But the point that would be impossible, since it is form which determines matter. So how can it be the other way around?
Actually, I wanted to ask you this as well, because I think the way I would formulate your argument is that form determines essence, but not form determines matter, because matter and form seem to be just two parts of every existing entity, or two, not even parts, but two things the human mind can perceive of every existing entity. So it's not like the form determines the matter, but the form determines the organization of the matter. That's what form means, and therefore I would say form determines essence, but not matter. What do you think to that?
Well, I would say both, that it does determine the matter because it determines what the matter is going to be. Because according to this Aristotelian principle, matter as such without any form is just pure potential. It is something which has the potential to be all sorts of things, but it can only be an actual thing once a form sort of limits the matter to be a specific thing instead of another kind of thing. And atoms is a good analogy, because atoms could be all sorts of different things, but it has the form which has to determine it.
Yes, but then the form would determine the thing and not the matter.
Well, it would determine how the matter is going to be, or actualizing the matter, to put it in Aristotelian terms.
Yes, but still the matter would just be whatever it is.
Well, it will be what it is according to the form, just as when you have an elephant, the form of an elephant is to be an elephant, the nature of an elephant, if you will. So all the matter that the elephant is made of is going to be determined, how it's going to be determined by it being a part of the elephant nature.
I think we are getting stuck a little bit here, but it seems
and also, if I could add.
Go ahead.
Yeah, there's also, this is worth noting, it's a difference between what is called accidental change and essential change. So this is what that means. Accidental change is change with a thing that doesn't affect its essence, its substance. It changes only the accidental parts, literally. So with human beings, for instance, you can have all sorts of accidental differences. One human being has dark hair, another one has light hair, one has one eye color, another one has another, height, etc. Those are accidental changes, because all of those people are still human beings. They have the same human nature. So that's accidental change. Essential change is this change within the essence of something. And that is what the argument would maintain is impossible, because something cannot act against its essence, because matter presupposes the essence in which it is in. But okay, we could move on to some other arguments or issues if you would like, or
I guess let's just present a couple of your arguments, because it would be a bummer if we get stuck in the very small detail of the first argument, and then yeah, we wouldn't get very far.
Okay, so another argument is the argument from the principle of proportionate causality. So what this principle of proportionate causality, is the idea that whenever we see causation, that we have a thing which is the cause and we have the effect. The cause causes the effect, literally. Whenever we have an instance of that, the cause must in some real way be greater than the effect, in the sense that the cause must have the power and the capacity to bring about the effect and all its qualities. The cause cannot be less than the effect, because then it doesn't have the capacity to produce something greater than itself. The cause must always be proportionate to the effect. And to put forward an analogy, you could say that let's say that I am going to give you $100. Now you could say in a philosophical way that I'm causing you to have $100, but the only way that can happen is that if I already possess $100 and then can give it to you, either whether I possess it directly, that I have it in my pocket, or I have the power to give you $100 by going to the bank and taking out money, or something equivalent to that. If I don't have somehow the power to give you those $100, that exchange will never happen. So, according to causality, the cause must be greater than the effect, or else the causation wouldn't happen. But it seems that according to the theory of evolution, we have seen something, some cause being lesser than the effect, in the sense that when we see the development of animals, we start off with very, very non-complex kinds of beings. And then through all sorts of instances of causation involving mutation, then the effect eventually becomes more and more and more complex, a higher form of being, eventually reaching human nature. But that's impossible, because you can't have something less producing something greater when it comes to degrees of being. Yeah, so that's a short summary of that principle.
Yes, I mean, what to say? I think this argument, many people that make arguments against evolution don't seem to fully understand the theory of evolution, because the idea is not that, let's say, small random causes produce something which is superior to that which was before, which indeed is very counterintuitive. But the point is, small random changes plus natural selection produce these effects. So the missing piece of the puzzle in your argument is that you change many things, or you have many examples, let's say, of the same small primitive life form, and then different of these examples change different small things, and then almost all of them are worse than the original one and they die. But if you do this experiment long enough, then eventually there will be some instance which is a little better by accident than the original life form, and then this thing will spread and the original life form will die out and only the better one will remain, and then you repeat the same process. And so by creating 99.9% waste, you can actually, through random causes, have something get to higher levels of complexity. Yeah.
Well, but even then, it's still the same truth that, according to the theory, when we discover, okay, what is the cause of that improvement taking place, it would be ultimately something lesser producing something greater.
Well, I don't exactly know what that means.
Well, I mean, the animal grew from a fish, then an amphibian, and then eventually to very, very high forms of animals like a platypus or dogs and even human beings. So that means that through the mechanism of mutation, it's true, natural selection is of course very central to that, but when we're just going to identify the cause itself, that which causes it is a lesser being producing greater being. And the absurdity becomes more apparent when you think about it in very ultimate terms, that a small set of chemicals in the water eventually, through time and mutations, produced a human being. It's true, it got a huge number of mutations and a long time, but it's impossible. It's just absurd on its face. It's not feasible.
Well, that's the point. I guess there are many examples of what you would call a lesser cause producing a higher cause, which I think would have to be better defined, what is meant by lesser and higher and so on. But just an example that comes to my mind, there are, in some places in nature, there are rock formations which look as if an intelligent being had ordered them. So you have like, let me think, you have, I guess you have like kind of a square of larger rocks, and then in between the larger rocks, all the smaller rocks are kind of aggregated. So it looks as if someone had ordered these rocks in a very complicated fashion by making kind of a structure out of the larger rocks and then filling the inside with the smaller rocks. But actually, the cause of this landscape is just that in this place there is a lot of earthquake activity, but on a very low amplitude. So the floor is always vibrating a little bit, and this causes the large rocks to slowly shift in one direction where the ground is a little bit lower, and then the smaller rocks kind of move a little bit upward because they are everything moves a little bit around, but the denser material moves downward. And so you get something which looks as if it had been ordered just by a vibration of the floor and having material with different property lying there.
Well, but even then, even if they are arranged a certain way, they're still rocks. It's not like they have become anything other than rocks. So it's not a new kind of thing being produced by something less. It's just a rearrangement.
Yes, but what then would you exactly mean by the cause being lesser than the effect?
Well, to put it more philosophically, it's a lesser form of being, but people can say it's less complex, it has less qualities, it has less power, just like, you know, that a tree versus, let's say, a monkey. We see that the monkey has powers and capabilities and fundamentally is something different than a tree, and is simply something a tree or something lesser cannot produce. And everyone would know, for instance, when we take it to the extreme, that chemicals in the water is obviously less than a developed human being.
Yes, but wouldn't you say that a vibrating piece of dirt is less than a neatly organized, beautiful structure that seems as if someone had created it purposefully?
Well, if it's still dirt, then it hasn't changed what it is.
Well, then, to be kind of the devil's advocate, human beings also consist of chemical substances. So the chemical substances haven't changed. They are just now much more complexly arrayed.
Well, we aren't just the chemical substances. We have to form as well. We have not only have we the highest form of human beings, which is intelligence and will, which also is impossible to be explained by evolution, but you have all sorts of things, the five senses, the digestive system. It's the whole human being is a completely different kind of being, far higher on the scale than mere chemicals in the water.
Yes, that is of course true, but yeah, I'm a little bit at a loss here because I feel many arguments against the theory of evolution make more or less this comparison. They take something which is extremely far removed in time, and they say, how could this have come directly out of that? And the point is, it didn't come directly out of that. As I have explained in the last video, the first step was just that the chemicals in the ocean sometimes by accident built amino acids, which is just a little bit more complex molecule than, for example, carbon dioxide and ammonia and these things. So that was just the first step, and that can actually happen, and people who study chemistry can explain how the balance of chemical equilibrium works in different circumstances. And so that's just the first step. That's the problem when you take a process that took like the entire Earth and a couple of billion years and crazy amount of input energy from the sun, and you just say, well, mutation caused chemicals to turn into a human being. Well, that's put like this, the theory really does sound absurd, but that's just because you reduce it so far that it's no longer understandable.
Well, I would say that it does really show that that evolution is truly absurd. It's true that yes, it has been a long time, billions of years, and lots of mutations, but it's still the case that actually occurred ultimately, and I would say that sort of establishes that it wouldn't make sense. Okay, but there are also other arguments if you want to get into those.
Yeah,
okay,
let's
so,
keep on going.
right, okay, let's see, there are yeah, this one is interesting. Okay, so this is perhaps more scientific-like argument than philosophical. So when we talk about animals gradually developing new features or organs, the problem is, it seems, and this has been admitted by prominent evolutionists, that the idea of some organ or some new function has gradually developed and then have natural selection do the job wouldn't make sense, because during this process, during which those new features or organs are being developed, they are just partially developed. They haven't fully developed yet, but when they are just partially developed, they have no function. They are just a liability, because you need it fully developed in order to actually be functional and be helpful and beneficial for the organism. I think someone mentioned the liver or some other organ, that it has to be fully 100% developed, whereas it's just going to not function at all and be completely a liability. Perhaps it wasn't the liver, but it was one such organ in the body. And Stephen Jay Gould, I think I pronounced that name correctly, a very famous evolutionist, he even admitted something like that and talked about what good is a half an eye or half a wing or something like that, which sort of establishes that yes, there are many features that need to be fully developed before they have any practical value. Just partially developed, they are useless. But during those very long periods of time during which those organs were merely partially developed, how would natural selection go about just continuing having those instead of them dying out? It doesn't make any sense. So how could natural selection bring it about to full development? So that's another argument.
Whoops. Yes. There are two interesting things to be said to this. The first one is that certain organs, like the eye, can develop while already being useful. It's like you have a very bad tool first, let's say just a rock that you use to smash a coconut open. And then, oops, are you there? I think you're frozen a little bit.
Oh, can you hear me and see me well now?
Hello?
Okay.
Yes, you were frozen a little bit.
Oh yeah, I see the internet connection is a bit unstable. Hopefully it will continue working. Can you see and hear me now?
Yes, I can.
Great.
So I will try again. So yes, the first point is that certain organs, like for example the eye, can develop while being useful at the same time. So an analogy would be how human beings use primitive tools to build more complex tools. So first they just took a rock and basically smashed something with it, and then at some point they used perhaps fire to burn a hole into a piece of wood and then squeeze the rock in there, and then you have like a primitive axe, and then you can chop down more trees and you can build more complex things. So that would be the evolution of tools. And now similarly, I think Richard Dawkins has spoken about this. There's even a Wikipedia article that I have looked up recently about the development of the eye. And so it seems that first there were perhaps a couple of worms, I think, that had light sensitive cells on the top of their head so that they know when they come out of the ground, because it's dangerous for a worm to come out of the ground because it can be eaten by birds. And so there were just a couple of cells on the head that basically say there is light or there is no light. And then as you build a kind of a depression, something like this, that is filled with light sensitive cells, then because of the shadow, you can say the light is coming from here or it's coming from here. So that would be a kind of improvement, that the light sensitive cells are not just on the surface, but they kind of cave inward and form this shape, and then it grows smaller and smaller, the opening, and the density of light sensitive cells increases. And so this is a way in which an eye can develop while the different stages are useful. Now, that's one thought, and perhaps you want to react, or I could also present the second thought.
Well, I would say that yeah, when it comes to the eye, I haven't sort of done an investigation very much into those theories. So I wouldn't comment necessarily on that, but I mean, I'm sure most people would grant that, yes, some features could be useful even in their gradual development. But surely there are features that are not useful during their gradual development. Someone mentioned the example of a bird getting a wing. If that came from some reptile and that was used to be a leg, in the process of that leg becoming a wing, it's useless. You have to have the developed wing in order for it to be any kind of functional in any way, or else it's just going to be a liability during that process. And I found a quote from Stephen J. Gould, and the quote is, "Of what possible use are the imperfect, incipient stages of useful structures? What good is half a jaw or half a wing?" And Gould is one of the most prominent evolutionists. He's deceased now, but he was one of the most prominent evolutionists, and he even admitted this. And vital organs, I mean, I'm not an expert when it comes to vital organs, but I'm sure there are many organs just in the human body that are such that they must be fully developed in order to be functional at all. And if they were just 50% developed, well, they would be useless because you need the whole development. So just to find one example which must be fully developed would crush the theory of evolution.
Yes, but I think this quote is, in my mind, it's just really stupid, because nobody says that kind of an animal all of a sudden starts growing a jaw, and then kind of after 1 million years there's like half a jaw sticking out of my face, and then it just keeps growing until it is complete, and then it has its function. That would indeed be a ridiculous theory, but that's not what the theory of evolution proposes. As I have explained before with the eye, so it is with many other organs, that they grew over time. So for example, no animal had half a brain at any point in time. The most primitive organisms don't have any nervous system at all. And then the next step of complexity is organisms where you just have some sensory cell and some motor cell, and they are directly linked by a connection. So for example, the motor cell says, if the water is warm, then swim here, or like there are these small robots that scientists have built that can seek a light source. And they are just very simple. They have a bunch of light sensors. And then whenever there is light on the right side, they activate the left leg or the left wheel. And whenever there is light on the left side, they activate the right wheel. And so when the light comes from the right side, then the robot immediately steers towards the light. And then when both sensors get light, it just drives straight. And so it finds the light source. And this thing literally just needs two neural connections, like one from this sensor to that motor and another one. And so that's a very primitive nervous system. And then over time, these animals developed more and more connections between sensors and motor cells. And then these connections kind of got channeled. And then you have this stage where animals kind of have a brain that is distributed along, or not, it's not a brain, it's kind of a proto-brain that is distributed along their spinal cord. So the spinal cord is kind of the brain. It's just all the connections run through there and then they go outwards. And then at some point you build like a big incremental steps, building a complex processing unit at one end of this spinal cord, and that's how a brain evolved. So there was never an animal that had like half a brain and then kept growing until there was a full brain. It's always incremental progress. And perhaps the other thought that I had is there are organs that lose their function over time in evolution. Like, I don't know, one example would be birds that can no longer fly. So, for example, there are many birds, I think about 50 or so, that can't fly anymore. Some, like the penguins, use their wings now for swimming, but others, like the kiwi in New Zealand, they just have little stupid wings that are good for nothing. And that's, of course, as you said, it's a liability, but actually the wings have gotten smaller. Birds didn't.
Oh, sorry, I just touched upon the pause button accidentally. So.
I saw it, but I think it's no big trouble. Yeah, so because actually these birds didn't need their wings anymore, once they were on an island like New Zealand where they didn't have any predators, that's why their wings started deteriorating. And so, yeah, I think I've talked a lot. I will let you say something now.
Yeah, I mean, when it comes to animals losing function, that's another issue, but we're talking about gaining function. And even in your examples with the brain and the spinal cord, well, how did the spinal cord develop? Could we have some sort of a primitively partially developed spinal cord? I'm not sure if that would make any sense. And just to use the example of the leg evolving into a wing, as Dr. Walt Brown pointed out in that book, it would be a bad leg long before it could become a good wing. So it's no way that natural selection could just pursue that course of action, because all those things would be liabilities. And many other things like arteries and all sorts of organs that are very complex, and they need all those parts together, it seems to me, to have real value. Or else if it's just 50% developed, or just this aspect is developed, it wouldn't be useful, it seems to me. So it wouldn't make sense. So yes, I think that would constitute a powerful argument. And again, even one of the most prominent evolutionists, Stephen Jay Gould, would say something like that: half a jaw or half a wing. I mean, evolution does entail that the jaw partially developed. It has to do that, or that the wing partially developed in this way. Well, that wouldn't make sense. It's not like every single thing in a body of every animal is somehow able to be useful, even just 1% developed, and just 2% developed. No, there are, of course, organs and functions that would be useless because they partially developed, because they have to be fully developed. So yes, I think that's constitutes a very powerful argument. Should we perhaps move on to the next, or yeah? Right, so I have written some things as well. That's why I'm pausing a little bit. Yes, okay, so entropy. That's not an issue which I have dealt very much into, but it seems to me to be a very powerful point. Okay, so entropy is the principle. It's really a scientific principle. It's reflected in the second law of thermodynamics. saying that things, I think it's specifically in physics talked about energy, in a closed system can only get worse. It cannot get better. That energy will eventually decrease into lower forms of energy. I think that is what the second law is about. And it reflects its general tendency of things, generally speaking, in the universe to decline in quality, to become worse, to become more defect, more dysfunctional. And this is true in all sorts of cases. Just take buildings. If they are not actively renovated and taken care of by human beings, they will eventually collapse if they are left on their own. All sorts of things, both human created things and human beings themselves grow old and die. So there's so much example of things getting worse. So that would really contradict the idea that something can become better and better and better and better massively over long periods of time when the then general tendency is decline. And especially when it comes to genetics, there is this principle of genetic entropy. And Dr. John Stanford, I think his name was that, wrote a book on genetic entropy, diving very much into this, that the general tendency of the genes contained in animals get worse, that there is actually a process of degeneration. And this seems to be the case just with human beings, that human beings are actually less healthy and more prone to certain diseases than thousands of years ago, that actually the genes are getting worse. And that could be accounted for instance, by when it comes to mutations. I've seen that most mutations are actually harmful. They are defects, literally, of the gene structure of something. Even if some mutations could be said to be accidentally beneficial, which evolution sort of maintains, still, generally speaking, mutations are either neutral or they are actually harmful, as I've seen. So there's always this tendency of degeneration when it comes to the genetic makeup of an animal, and not regeneration or improvement. So that would contradict evolution, which says that things, and especially the genes, have gotten way better, all the way to getting from chemicals in the water to become a human being. But that would contradict entropy. According to entropy, things would actually decline, get worse, which suggests things were better in the past. So yeah, that's a short summary of the argument.
Yes, again, I have to say that the argument is not true, because the point is the Earth is not a closed system. The sun pumps a huge amount of energy into this system every day, and the Earth radiates energy off into space via infrared, like thermal radiation. So the Earth would cool down if the sun wasn't heating it up every day. And so the Earth, in that sense, is not a closed system, because energy is coming in. And so it's not true that the quality of energy in the system Earth has to decrease because there is fresh energy coming in. Now, the theory of entropy is a scientific theory, and it's, in my mind, this makes me wonder how this Big Bang theory should have worked. But it doesn't have anything in my mind to do with evolution, because evolution is a hugely inefficient, wasteful process. As we have said, and you said it correctly, most of the mutations are harmful. Most of the changes of some specific organism are making it slightly worse. But then you have natural selection that kills all of the slightly worse mutations and just leaves the slightly improved ones to again make millions of variations, from which almost all die, and just the best ones make again millions of variations. And so the process is extremely wasteful, but energy from the sun is coming in every day, and that's why it can continue, and that's why it can reach higher levels of complexity. If you would take the entire universe, or let's say for our purpose, the entire solar system, then the law of entropy would apply to it. So that means the state of the sun is becoming more chaotic than the state of the earth is becoming ordered. So in the total sum, the chaos is still increasing. But in a local small pocket, let's say the earth, it can still be that the chaos is decreasing because more chaos is increasing in another place in the system.
I didn't understand the last part, that more cases, less chaos in the earth, but more chaos in the universe.
Yes, let's make a simpler example. So let's say I am cleaning up my room in my house. So I am actually reducing entropy in my room. I am literally making order out of chaos. So some people could say, well, you can't clean up your room because that contradicts the second law of thermodynamics, namely that entropy always increases. But the point is, as I am cleaning up my room, I am burning calories. I have a chemical process inside of my body that makes some atoms or some molecules change from a complex, well-ordered state into a less complex, more chaotic state, because I'm burning sugar and making carbon dioxide and water out of it, which is a less complex molecule and therefore increasing the entropy. And so as I'm cleaning up my room, I am actually increasing the entropy of the entire system, but locally in my room, the chaos is decreasing. While if we take into consideration the number of possibilities of how air molecules are organized, then the entropy is increased.
Well, I mean, that's something different though, because then you have an agent with free will who chooses to change this. Obviously, human beings can change some things, but we're talking about the general tendency of things in themselves. So that would not be the same, I would say. So, I mean, the thing about entropy is that eventually, when we talk about accumulation, it will accumulate more and more harmful things. It's true that you have natural selection, but it's not clear to me that that would sort of get rid of the fact that things are genetically deteriorating. It seems to me to be the case with dogs, for instance. All the breedings that human beings have done with dogs have eventually degenerated dogs. The different types of dogs that are today, some of them are genetically speaking very inferior to their ancestors thousands of years ago, which were basically wolves, it seems to me. But today you have Chihuahua and all sorts of animals, dogs that are genetically speaking much more degenerate. And that seems to me to be the case, generally speaking, with animals, that there is always this decline. Even with natural selection, it seems to me that there is this decline and things getting more and more degenerate, genetically speaking.
Well, this is actually really easy to refute, because it's just not the case. When, of course, Chihuahuas are bred by human beings to be small and look cute, and in that sense they are better than wolves, because wolves are not small and cute. So, but that's, I think, a complicated issue, because, as you said, humans have free will and it makes things very complicated. But if you look at the interaction, let's say, between wolves and deer, then all the wolves eat the deers that aren't as fast as the other deers, because they chase the deers and the slowest deer gets eaten. And so the genetics of the deers are, every day they are being trimmed. All the bad variations are getting cut out because they are eaten and then they no longer exist. And the same thing, of course, is true with the wolves themselves, because the wolves that are bad hunters, they starve, and only the good wolves remain. And so natural selection does exactly that. It cleans out the degeneration of the genes, which happens because of entropy?
Well, it might weaken the process, but it cannot extinguish altogether the general tendency of degeneracy. Natural selection can only do so and so much, so I wouldn't say that can completely solve the problem.
Well, let's perhaps move on to the next one, because I would just have to disagree.
So yeah, this seems to be okay. So this is more of a general point. So in addition to these philosophical and scientific arguments against evolution, there is also the problem of where is the evidence for evolution that it's actually happening? Because it's true that there are many examples of what is called microevolution or adaptation, where you see animals adapt and have some genetic differences, just as with dog breeding, that there will be variations. But we don't have any examples, any scientific observations that you actually see something changing the kind of animal it is, something changing its substance. There is no scientific evidence for that, and people point to things like the fossil record, but the fossil record doesn't prove evolution, because all they prove is that yes, here we see a lot of many interesting creatures that existed but are now extinct. That doesn't mean that they all have a common ancestor. Another thing, people point to vestigial organs. Well, that's a logical fallacy, because just because we don't know the function of something doesn't mean that it doesn't have any function whatsoever. And there are vestigial organs, so-called, which actually turn out to have a function. So yes, that would be a question: where is the scientific evidence which shows yes, evolution did definitely happen?
Yes, I mean, that's an interesting question, and I'm glad you brought it up, because I have collected just 3 or 4, actually, yeah, examples in my mind, but of course you kind of took them away right from the start when you said vestigial organs do not prove evolution, and that's true. I mean, that's like me saying 10 million eyewitness accounts about the life of Socrates or the life of Jesus Christ doesn't prove that this person actually existed. You cannot directly prove that something happened in the past. You can only look at things that still exist today and infer from that a theory about the past. And so when you see, I think this was Charles Darwin did a lot of this work. He looked at the anatomy of animals and he said, these animals all seem to have a similar bone structure. So there is always one bone in the upper limb and then 2 bones in the lower limb. And he saw this in different animals, or he saw that bats have like extremely long fingers with skin in between, and these are their wings. And he counted the number of bones and saw that they are the same number as in human beings and monkeys and cows and dogs and cats. They are just of a different length and of a different thickness. And so he said, it seems to me the most plausible explanation that one of these animals slowly developed by just gradually lengthening and thinning this bone as compared to this other animal. But you cannot exactly prove that this has happened, because you cannot kind of install cameras and observe the past couple of million years on all of Earth. So yeah, that's of course true. But when it comes to scientific theories, what they try to do is they look at the available data and then try to find the most elegant solution to explain this occurrence. So this has to do with Occam's razor, that the theory which can explain the same amount of data but is simpler in itself is the better theory. Now, not everybody might agree with that, but at least that's what science does, and it has been quite successful with it.
Well, first of all, when it comes to those discoveries by Darwin, I assume you're referring to his discoveries on the Galapagos Islands. Is that true that the Galapagos were very famous? Because he traveled to these islands in the 19th century, and he discovered some similar features between some, I think it was birds. But yes, I mean, everyone would agree that there is microevolution, that you have variations within a specific kind of species, or even there is this concept of ring species, where you see some birds interbreed one place at Earth, but not other places and things like that. But there is no way that can show that there is a change of kinds, that dogs can become cats, to put it in a very crude manner or explicit manner, that you cannot change the substance or kind of something. Right, so there wouldn't be any evidence for it. And also another point, which goes against evolution, is that if evolution were true, it seems that we would expect to see a lot of transitional fossils in the fossil records. That is, fossils where we can clearly see, oh, this is evolving from this past kind of animal and it's about to become this other kind of animal. But it seems that the fossil record doesn't contain any such transitionary fossils. And I can quote an evolutionist biologist named Colin Patterson, a British paleontologist at the Natural History Museum in London. And he wrote a book called Evolution, and he was asked later, why didn't he include any pictures of transitional fossils in that book about evolution? And he answered, quote, "I fully agree with your comments on the lack of direct illustration of evolutionary transitions in my book. If I knew of any, fossil or living, I would certainly have included them. You suggest that an artist could be used to visualize such transformations, but where would he get the information from? I could not honestly provide it, and if I were to leave it to artistic license, would that not mislead the reader?" So basically, there seems not to be any transitional fossils, but if evolution were true, I suppose we would expect to see many of them. So that's another point. So when it comes to this idea of Occam's razor, that the best explanation is the simplest one, but it's true that that would be an advantage to a scientific theory, but it also has to, we could say, fulfill other things like being plausible and also having explanatory scope. And most certainly it's not plausible, as I have argued, and there are many problems with it, as I've argued, and also it would, you could say it would contradict some other facts that we know, but yeah, we don't necessarily need to get into that. So yes, and one comment I would make of this is that evolution, this is touching also upon the implications of evolution, is a very, very common reason why people reject religion and intelligent design. Richard Dawkins said that evolution, the Darwinian theory, made it possible for him to become an intellectually fulfilled atheist. So it seems that evolution has been a very strong factor in discrediting the idea that animals on Earth are created specially by God. But if we don't see any evidence for scientific any scientific evidence for the theory, then we immediately see, oh, intelligent design and special creation become much more serious alternatives now. And that I would say is very important, because it can bring back openness to theism and intelligent design and Christianity, etc. So those are more implications of evolution, but yeah, those were 2 points I had.
Yeah, I mean, to the last one, as you said, these are implications, but they don't concern the truth value of the theory itself.
That's true.
So we can leave that for the moment. I don't know much about the fossil record discussion. I really don't know much about that, so I can't really comment on it. But I would like to stick a little bit more with this statement of yours that there is no scientific evidence, and also that there is only microevolution but not macroevolution. And the first thing I would say is human beings are just not, we cannot, or have not at least, but I don't think we can realistically run an experiment where we, let's say, take an entire continent or half a continent and lock it down for 100 million years and observe the change in the gradual change of the animals that live there, and then say, now this gradual change has accumulated long enough so that this is now a new species, and so we have now an observed example of macroevolution. But I would like to bring up one example because I think this is a particularly striking example for evolution and against intelligent design, and that is the giraffe. So this animal with the extremely long neck. And in the giraffe, there is a nerve. It's called the laryngeal nerve. It's the nerve, I think, that has to do with this this organ, I don't know how it's called in English, that creates sounds like the vocal cords or something like that. And this nerve in all mammalia travels from the brain down into the chest and then goes under one of the heart arteries and then goes back up the neck to the vocal cords. And so in most mammalia, this is not a big problem because it just kind of leads to like 10-15 centimeters longer nerve than it should have been or that it would optimally be. But in a giraffe, this nerve is actually almost 2 meters longer, or perhaps even 3, I don't know exactly, than it would sensibly have to be, because it could just go from the brain to the vocal cords directly, but instead it goes down all the long neck, loops below this artery, and then goes all the way up again to the vocal cords. And so first of all, you have to ask yourself, which intelligent designer would create this nerve in this fashion? And secondly, it kind of makes the theory more plausible that a giraffe evolved by having some animal whose neck gradually grew longer and longer. And so this nerve just got longer and longer because evolution cannot just change the nerve going from some place to some other place by directly rewiring it. It can only change incrementally. And that's why the giraffe ends up with this ridiculously long nerve that doesn't have any purpose being so long. It could just as well go directly.
How do you know that it doesn't have any purpose?
Well, we are pretty sure about what the purpose of a nerve is. It is to transmit a signal from the brain to an organ. And so there is no need for the nerve to be very long and going down there and then coming back up.
Well, how do you know that?
Well, I would have to say I assume it based on our knowledge of how nerves work.
Well, I mean, perhaps there is something about the giraffe that thus make that useful, that we just haven't figured it out, or perhaps some have figured it out. I will check more about that later and see, look more into it. But actually, it's interesting you brought up the giraffe, because there is this documentary series called Incredible Creatures That Defy Evolution, and it talks about all sorts of animals living today that are very complex and have features that wouldn't make sense according to evolution. And it actually talks of the giraffe and certain features and functions that it has that would be such that it has to be fully developed. All of the parts need to be there, or else the giraffe would have serious problems surviving and it would go extinct. Now, unfortunately, I don't remember enough about that argument to present it very well here, but I will recommend everyone to watch Incredible Creatures That Defy Evolution. Those are actually online on YouTube. They can be watched for free there. And the first episode, there are multiple episodes. The first episode deals with that giraffe. So actually the giraffe can be used as an argument against evolution. But yes, when it comes to that nerve in the giraffe, I will probably look that up and read more about it, because I haven't learned about it until you mention it now. So yes, I will do that. Now it seems that we have talked for about a little over an hour, and I am thinking of going and eating some things. So if it's okay with you, we can end the conversation here and make some closing remarks. Okay, so I will begin by saying this has been a very interesting discussion of the theory of evolution. And I maintain, based on the arguments I presented and other things could also be said, because it's a huge topic, that evolution is false, that there are many good arguments, both philosophical and scientific arguments against it. I would say it's really absurd when one thinks about its ultimate implications. And I would say, yes, there is no real scientific evidence for it. I would say that actually intelligent design is not only scientifically the more plausible theory of explaining things around us. We haven't really got into arguments for intelligent design in this discussion. Perhaps we could do that in a later discussion. But yeah, so I would be against evolution. It's false. It's irrational. There is no evidence for it. The arguments are very powerful arguments proving that it's false. And I would therefore maintain that evolution is false and that intelligent design and special creation by God is true. Amos Zweig here would of course disagree, but that is my conclusion. And again, this is a huge topic, and more can be said and read about it. I intend to read more about it in the future, so and cover more points. So yes, thank you, Amos, for joining me in this discussion, and thank you to the audience who have watched this. And I will then end by wishing you, Amos, and the audience a good weekend.
Thank you very much. I think it was interesting to go through the arguments. I think none of them stand, in my opinion, but yeah, we will have to leave that open and everybody can make up their own mind. So yeah, it was productive, I think, and I wish everyone a great weekend and see you all later.
Okay, goodbye, everyone.
Goodbye.